In this video, I'm going to walk you through how I wire Dr. Carlotta Berry's DaisyBot for foundational connection and movement control. This is a simple circuit with two Dagu motors, an Arduino Mega, and a TB6612 driver integrated circuit on a breadboard. The aim of this circuit is to provide basic functionality without any sensors or additional features. Hopefully this video provides you with an easy-to-follow example of how to initially wire the DaisyBot. The first step I'm going to take is connecting the Arduino ground pin to the breadboard's ground bus. I'm going to just bring that connection over to the horizontally connected rails on the breadboard so that it's easy to connect to the Arduino's ground from now on. Now, I'm going to connect the ground pin of the motor driver to the rail where the ground connection now lives on the breadboard. I'm adding another connection to the Arduino's ground pin by connecting the ground pin on the left side of the driver to the ground bus that we've created. This is to provide a more stable ground connection and reduce ground noise. Next, I connect the driver's V motor or Vin pin to the Arduino's Vin pin. Now I make a connection from the Arduino's 5-volt pin to the breadboard's power bus. Okay, so I'm going to bring this connection over to the driver's voltage input pin or the VCC pin. For reference, the voltage range for this driver's logic level is 2.7 volts to 5.5 volts. Now I'm going to take the DC motor's voltage wire to a new horizontal rail. I plug a wire in a hole in that rail to establish a connection and bring it to the driver's motor A top pin. The order of this matters and will dictate the direction the wheel turns in when forward or backward is called. To finish wiring this first motor, I place its ground wire into a new horizontal rail in the breadboard. I take a wire and plug it into a hole parallel to the ground wire, and then I plug it into the driver's motor A pin. Next, I'm going to do the same with the other motor's wires, but connecting them to the driver's motor B pins. So first, I'll plug the ground wire of this next motor into a new horizontal rail. Then, I'll plug a new wire into a hole next to it and connect it to the driver's motor B top pin. Now the voltage wire from the motor can go into its own horizontal rail. I'll place a wire in a hole next to the voltage wire and bring that to the bottom pin of motor B on the driver. So I'm going to plug this wire into the driver's AN1 pin and connect it to the Arduino's general purpose digital pin 2. The digital output pin is used to form a connection that will be a part of dictating the direction of motor A. It is used in combination with AN2, which I'm about to wire right now. So I'm going to take this wire and connect it to the driver's AN2 pin to the Arduino's digital pin 4. In code, these digital Arduino pins are set to output pins. Next, I'll plug a wire into Arduino's digital pin 3 and connect it to the driver's PWMA, which is the pulse width modulation pin for motor A. This connection allows the Arduino to control the speed of motor A by sending a PWM signal from the Arduino to the driver. Now, I'll connect the driver's PWMB pin to the Arduino's digital pin 5 to control the speed of motor B. The last wires to connect are the driver's BN1 and BN2 pins to control the direction of motor B. I'll start with connecting the wire to the driver's BN2 pin. Then, I'll plug the wire into the Arduino's digital pin 7. Next, I'll connect the driver's BN1 pin. And the last thing to do is bring that connection over to the Arduino's digital pin 6. Thanks for watching my video on wiring Dr. Carlotta Berry's DaisyBot. I had a lot of fun putting this together, so I hope you found it helpful and had just as much fun with your DaisyBot. In the future, I hope to release another video on extending the functionality of this robot with a few sensors. If you're interested in learning more about the exciting possibilities of these flower bots, be sure to check out Dr. Berry's channel and social media platforms. Thanks again for watching.